I was running a $1 million laboratory at California State University, Northridge. I have over 30 years experience in microscopy, and that is a scientist who uses microscopes. And I've worked for all the big microscope companies. And so Cal State Northridge hired me to build a lab from a brand new building. I was up the top of a brand new building, a science center, at California State University, Northridge. And they gave me a suite of laboratories at the top of this $50 million building. And they said, Mark, build us a microscope lab, put in it all the microscopes that we're going to need for this department, learn everything you need to know about the new instruments that you bring in, and then we want you to train everybody in the department on these instruments. We want you to train graduates, we want you to train undergraduates, and we want you to train professors who are the worst students of all. Literally, most of the professors were dumb as a bag of hammers, and I had so much more success training the students than I did the professors. That's a whole nother story. But I went on a dinosaur dig in 2012. I started my job in 2010, and after 2 years of running this laboratory, and everybody was thrilled. Mark, you're doing a great job. We love what you're doing. The students are learning. The lab is full of students all the time. Now, I was only there 2 days a week because they could only afford me for 2 days a week. So I was told I was a part-time permanent. Part-time permanent. And so as the lab grew, they said, can you work more? Can you teach more? Can you come in more days? And I was running my own microscope company, so regrettably I could not. And so, well, can you train more people? Can you train? And so finding a person who had my experience to learn the things that I knew was virtually impossible. So they videotaped me. They did 12 hours of videotaping of me, and they would make the students watch these 12 hours of videos and take some online tests before they could come into my laboratory, but at least they had a background of training. Anyway, that's all background. In 2012, I was invited to go on a dinosaur dig in Montana. There's a reason they call it the Badlands, because it's really bad there. The only thing cool about the Badlands of Montana are the antelope, which bounce. The antelope bounce around. They're so cool to watch. Everything else is horrible. It's hot, it's dry, it's dusty. There's bugs everywhere. The dirt, all you have to do is stand there and the dirt finds every part of your body that's not covered in dirt. Seriously, at night I would take a shower and I would have a ring of dirt around me in the shower, and I was afraid to put it down the drain. I would scoop it out and put it in the trash can because I thought, I don't want to wreck the hotel drainage system here. But we went to Montana. We dug for 3 days and didn't find anything. Now, what were we looking for? We were looking for long bones. You've heard of a femur, right? Femur bone is a long bone. Why were we looking for femurs or long bones? Because a professor at North Carolina State University, Dr. Mary Schweitzer, had also dug in Montana, the same place that we were digging, same ranch we were digging, and she found a T-Rex long bone. Now, I always heard that by the time, because when you dig a bone out of the ground, a bone like the ones you see, you paint them with a glue first. You don't disturb them. You uncover them as much as possible. You paint them with a glue, and then you put tin foil on them, and then you put plaster like you would have a cast on your arm. You put wet plaster, like the casting material, wait till it dries, then you flip it over and do the same thing, then you take the bone out. Well, this obviously makes the bone really heavy. Now, the story we had heard was the bone was too heavy to be carried out by helicopter. And I always wondered, why a helicopter? You know, why not a truck? Right? Why a helicopter? And so for years, we didn't know the story. Well, we heard the backstory finally when we went the third time to Montana this last August. And here's the backstory. All the evolutionists had been digging on these ranch lands in Montana. And the ranchers were sick of them. Sick and tired of the evolutionists. Why? Mean, nasty, you know, not grateful, just all the things that you would expect an evolutionist to be. Now don't get me wrong, I'm not, forgive me, Lord, I'm not picking a fight with evolutionists, okay? And I'm not really trying to characterize them. But anyway, so the ranch owner, across her ranch they would have to drive to take the femur out, was so sick and tired of the evolutionists, she said, "You're not driving that thing across my property." So they had to get a helicopter. Now, nobody ever told us the backstory, and we know Marge, the ranch owner, she's awesome. Marge is awesome. She wears a 38, or maybe it's a 9mm, right on her hip. You'll see a drawing of her tonight. She rides a quad. How old is Marge? 75? 75. And she's got two rifles strapped to the front of the quad. Awesome, awesome lady. And she knew that they had found one of the most important T-Rex finds ever found. And she was so upset with these people, "You're not driving that across my property. You get back on the main highway." So they had to helicopter it out. Well, they couldn't helicopter it because it was too heavy. So what did they do? They had to saw this femur in half. Now, why am I telling you all this? Because Mary Schweitzer was a graduate student at the time. She was working on her PhD, and she gathered up a lot of the pieces that came out of that T-Rex femur. She shipped them back to her lab in North Carolina, and she soaked them in a weak acid. Why would you soak a bone in a weak acid? Because every time a hospital takes a bone out of a patient for whatever reason, maybe it's a malignant piece of bone, they take it out, they want to look at the tissues in it, they soak it in a weak acid. That's what every single pathology department in every single hospital all over the globe is doing. And Mary Schweitzer happened to have hospital training. So for her it was normal to put these bones in this weak acid, and she told her tech, okay, put these in the weak acid, it's called EDTA, put them in EDTA, and then come back and tell me what you got. Well, the tech came back because there was all this squishy stuff in the vessel, right? Soft tissue, squishy stuff. She comes back to Mary and she says, "I found squishy stuff." "No, you did it wrong, go do it again." This happened 10 times before Mary finally looked under her microscope and realized, ay, 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 caramba, these are blood vessels that have red blood cells in them and osteocytes. Osteocytes. Now these are bone cells. An osteocyte is a bone cell. Your skeleton, your bone is living tissue, just like all the other tissue in your body. And it is fantastic. It is the most amazingly engineered living tissue that you'll ever come to know. And it's all run by these little cells called osteocytes. Osteo meaning bone, cyte meaning cell. Bone cells. Your skeleton is completely replaced with new bone every 13 years. Okay? Why? Because these guys are busy measuring and monitoring and checking. When you're lifting boxes and heavy things and babies, when you're lifting babies, let's make it practical, yeah? When you're lifting and you're putting little cracks in your bones, these guys are measuring the cracks in real time. You talk about our sophisticated computers, okay? And you say, well, what are all these little lines coming? Here's a cell, here's a cell, here's a cell. What are all these lines coming off of them, these little tubes? They're called thread feet, Philopodia. Thread feet. They're all touching each other. All of these cells throughout your skeleton are touching each other. They're all in communication with each other. And they're talking to each other. They're saying, Fred, up in sector C49B12, there's a micro crack there, and you got to fix it. So what happens to Fred? Fred becomes a bone dissolving cell, and he literally, like an amoeba, goes through the bone and just dissolves what's in his path. And then another osteocyte comes behind Fred and rebuilds the bone. And some of these cells, the ones that monitor the bone, they encapsulate themselves in bone. They literally cover themselves up in bone, but they build into the bone little tiny tunnels, canaliculi, little tiny tunnels that travel in every direction, and they put a thread foot through there, and they touch the cell above and below and to the side. They're all, this is an amazing, amazing system. So this is what we call recent. Okay? There's job security in science because of the terminology, I'll tell you. That's no lie. They really, every 8 years they change the terminology so they keep their jobs. But this is what we call recent. This was taken from a mouse a few days before they actually looked at it under the scanning electron microscope. Now, a scanning electron microscope is a microscope that uses electrons instead of light. These bulbs are giving off photons of light. And compared to electrons, photons are like basketballs. And electrons are like BBs. And why do we use electrons? Because they're so small that we can measure smaller and smaller things. It's like your ruler. If you try to measure the facets on a fly's eye with a yardstick, how are you going to do with that?
Very good.
Yeah, right? So you got to use one of the rulers that comes with your calendar, right? Now you can measure the facets on a fly eye, right? No. Okay, maybe a ruler that's the length of your fingernail. That's a good one. Now you can measure the facets on a fly eye, right? You're going to have to use a ruler so small that your eye cannot see it in order to measure the facets on a fly eye. So electrons are bigger than photons. Regular microscopes use light, photons. Electron microscopes use electrons. So we can see things that are really small. How small, Mark? These little Philopodia right here are about 200 nanometers wide. What's a nanometer? What's a nanometer? Okay. Pluck a human hair, magnify it. How wide is a human hair? About 100 microns. Okay? 100 microns. A micron is a billionth of a meter, but we won't go there. Let's use a hair as our scale. 100 microns. Now what's 1 micron? Picture 1/100th the width of one of your hairs. That's 1,000 nanometers. And we're looking at 200 to 400 nanometers. Pretty tiny, right? So that's why we use electron microscopes. Now, I went to Montana and dug for 3 days and found nothing. No long bones. Why were we looking for long bones? Because our thinking was soft tissues, like Mary had been finding, are better preserved inside a bone that is massive and fully encapsulated. You understand what I'm saying? A thigh bone, a femur, is a massive bone with a lot of thick bone around it, and even at the edges, and it's not until you get way inside that you have the marrow and the blood vessels. Now, truth be told, the blood vessels actually go through all the massive bone too. That's why when they kept dissolving these little shards of the femur, the massive bone, they were releasing the little blood vessels that were inside even that hard, compact bone, right? So this has been a learning process for everybody. But I was reading this stuff and looking at it and thinking, Mary is using microscopes. Now, I'm a microscopist of 30 years. I can do this. And she's not glorifying God with it. She's not telling the truth about how old these things really are, because I don't hold to 68 million years old. I hold to the Bible, which has a different story, right? Maybe an earth that's 6,000 to 10,000 years old. Okay, maybe even a little older than that. I don't have a problem with that. A lot of Christians have a problem when you go past 6,000 years. I don't have a problem with that. Why? Because you cannot get a man from a frog in a million years. Can you? Can you evolve a man from a frog in a million years?
No.
No. They're saying it takes millions and hundreds of millions of years. Now, I could say to them, well, you can get a man from a frog in a second. Really? All you need is a princess. Right? A princess. And you know right where I'm going. Okay? And in a second, the princess turns the frog into a man. Now think about this. Think about that 1 second. Think about the way they stretched that out to 100 million years. And you still have the same fairy tale. Right? So that's where I'm coming from. I'm coming from a position of the scripture being quite plain that we haven't been here very long. The earth has not been here very long. And so when I look at a Triceratops horn, man, I would have loved to walk around with these guys. And according to scripture, when all things will be restored, see, I think heaven is Eden 2.0. I do. As a biologist, I think God is a biologist, you know? And I think He wants us to walk in purity and in holiness with the biology that He made. It got messed up in the beginning, didn't it? It's not going to be messed up when all things are restored, right? So I have some crazy ideas about that, but man, I can't wait. So when I see Mary Schweitzer finding osteocytes and finding blood vessels and finding red blood cells and other things inside of dinosaur tissues that she says are 68 million years old, and she will not give that up. By the way, she is a Assemblies of God sister in Christ. You should pray for Mary Schweitzer. Why? Because she's close. She's so close. All she's got to do is give up the stretching of the second. And she's there. You see? But I realized I can do this work. So I got all excited, and off to Montana I ran. 3 days of digging, nothing but dirt in my bathtub. And the third day, knowing I was going to have to get in my car and drive back to LA, and praying, Lord, please. And we're talking to Maggie, and we call her Maggie. Marge is her name. We call her Maggie. And she says, you know, I think I saw a piece of Triceratops horn sticking out of a cliff. And so she led us to the side of a cliff where a 48-inch long Triceratops horn, I should pass this around, just let you guys feel the weight of this, was sticking out of the side of the cliff. Actually it was the other end. The point was all the way in, and the other end, in fact, at the end of the horn, and I wish I had, I brought a different presentation tonight, guys. I'm winging it here. The other end of the horn actually had part of the skull. Wow. I tell people, This stuff rolled around in the mud like it was in a cement mixer. Everything got torn asunder. You know, the evolutionists have these sweet little drawings of an animal keeling over, you know, and falling into a stream and slowly. No, this was hugely violent. So to find something like this is rare. And so we dug this out, we painted it, we put tin foil on it, we put plaster on it, we rolled it over, and it broke into about 7 pieces. And we thought, oh my, you know, all the 8 hours of digging wasted. And it was full of plant roots. It had plant roots growing through it. When I looked at two of the pieces, I separated them a little bit. I saw all this fungal mat, white fungal mat in there. By the way, we did what's called a blast DNA analysis. What's that? We took the samples of soft tissue, we just threw them in a machine and said, show us what you got. And we found the DNA of 30 different organisms, including rodents, insects, tons of microbes. And think about this. This is not a femur that's completely encapsulated. This is a bone that's full of blood vessels. You see all those holes? Those are blood vessels. And they're laying in the mud 2 feet from the surface of the Montana Badlands, okay, subject to water infiltration, mud infiltration, insects, microbes by the billions. How could there be any soft tissue left in here? Okay? Well, now I want to show you some pictures of what I found. Am I winging it okay? Am I doing all right?
Great.
So this is a recent, taken from a mouse just before the picture was taken. Here's what I found. Now, not to brag too much, but if you look at Mary Schweitzer's pictures, they're nowhere near the quality. Oh darn, did I delete that slide? No, wait. There it is. I worked so hard to put this slide together just now. When you look at her pictures, the osteocyte cells, and let's turn off the lights. I really want you guys to see this. The osteocytes that I was able to photograph, and is that as focused as we can make it? I don't know. What I want you to see, I want you to see these little Philopodia around the outside and the surfaces. I apologize. Here you can see some. I apologize, but you know what? I'm going to give you a blog site you can go to. And I have about 100 pictures of these osteocytes up on the blog. And
now these are Mary Schweitzer's pictures?
no, these are my pictures. They're so much better than hers are. And again, I'm sorry I didn't set up to give you the introduction here. I thought you guys would all be aware of the talk that I did last year, remember?
Yeah.
Okay, but not so. But we'll give you a blog site. In fact, we have a flyer here. And I don't know how many we have, but you might have to share, maybe one per family. But it talks about our YouTube channel. We got videos on YouTube. Talks about our blog site. And you can see all these pictures on the blog site. And I want you to see them because they're some of the best pictures ever taken of dinosaur osteocytes. Why do I say that? I did a talk. I've done like 4 scientific presentations at different societies now. And thank God they've let me come in and talk about it, which is an amazing open door that I need you guys to keep praying about. But I spoke at the International Microscopy Society of America meeting in Hartford, Connecticut last summer. And I'm in a room full of PhDs, not unlike this room, a little bit bigger, full of PhDs. And I'm thinking, okay, Lord, here we go. So I did my presentation, and at the end, a PhD from a major university came up to me and she said, Mark, I want to collaborate with you to culture these cells. What was she saying? I recognized that these guys look alive, and I want to try to revive them with you. See? That's how astounding these pictures are. So it's been a wild ride. Oh, by the way, the university fired me. Why did they fire me? Well, I published my results in an international journal called Acta Histochemica. And I also published a journal cover. And everybody in the department was wildly happy. Great job, Mark. You're doing good. Love the publications you're doing. Brings prestige to the university, except for one guy. One guy who came to my lab and he banged on the door. Why did he have to bang on the door? Because my lab had an Omnicode lock on the outside of it. That's one of those where you have to punch in the code to open the door, or you can't get in. Now here's a full professor in the department that did not have access to my laboratory. Why? Because he hadn't taken my training. He hadn't sat under my tutelage and gotten my seal of approval so that they would give him the code so that he could punch in the number and come in. No, he had to bang on the outside door until he got my attention, so I opened the door and he brushed past me and said, "We're not going to tolerate your religion in this department."
No kidding.
No kidding. And I said, while I was trying to catch my breath and not strangle him, "Ernie, I think you just broke the First Amendment to the Constitution.
Keep your feet out."
And number two, what is unscientific?" See, he used the word religion. What is unscientific? I was trying to be diplomatic. What is unscientific about soft tissue and dinosaur bones? In other words, we're on a science stage here. We're in the field of science. So argue, Ernie, with me about the lack of scientific merit for the work that I've done and published, okay, and have received accolades for it. Well, we're going to have this conversation in front of your supervisor. Well, I hope so, because you just violated my First Amendment right. And so he stormed out, and I emailed a complaint to my supervisor in writing. You should know what just happened in my lab. My supervisor came in, put his arm around me and said, "Mark, you're the best thing since sliced bread. Keep doing what you're doing. I don't care if you are a druid." That's what he said to me. "I don't care if you're a druid. Keep doing what you're doing. Pat on the back. Let it go. Don't worry about it." I shouldn't have let it go. In retrospect, now, you know, hindsight is always 20/20, right? I should have made a big deal about it. Sadly, that's the way it has to be in this society, isn't it? The chairman of the department came up from the bottom floor, all the way up to my lap, put his arm around me. "Mark, you're doing a great job. You're fabulous. You're just what we wanted. Don't worry about this. Let it go. It's not a big deal." Again, I shouldn't have let it go. I should have pressed the point. But I didn't. And Ernie, a year later, became my supervisor, and I was out. There was a big lawsuit. Maybe you've heard about it, maybe you haven't. And this is the part where I'm going to launch now into the talk that I had prepared. And a lot of this is technical, so I'm going to work really hard to make it non-technical tonight. But I assumed that you guys would have already known about my career at Cal State Northridge and my termination. If you don't, just Google CSUN Dinosaur. You don't even have to even Google my name anymore. This is so big. There's about 80,000 web pages on this now. Okay, maybe more. Just Google CSUN Dinosaur, and you'll see it. We filed a lawsuit in Los Angeles Superior Court. We're about 1/3 of the way through the lawsuit. By the way, I went through 6 lawyers before I found the 7th one who would take the case. 6 lawyers I went through, and it was down to the wire where we had to file. And I think we filed like the day before the clock ran out, right? 6 lawyers. Well, the 7th one just quit last week. Okay, so this has been, Satan does not want this to go forward because he knows this is a lit keg of explosive powder. So I need your prayers. I need your prayers. The university should have followed up on my complaint. The rules are, I mean the federal rules, let alone the university rules. The federal rules are, you're required to follow up on this, do an investigation. If someone committed something like that, they should be retrained. I mean, the Christians will get retrained in a heartbeat, right? Don't say anything about the Muslims. In fact, come in here and take 12 hours. I need to hurry it up. I'm going to run out of time. This has just been my introduction. Are you okay with that? And I still have 2 hours to go. How long can I go? How much longer do I have?
At 8:30, you know, anybody that
Okay.
needs to leave can walk out.
Okay.
But you can go on longer if you want
Okay,
to.
so at 8:30 we'll call it quits and then we'll do part B, okay? All right. Where was I? And that clock is right? It's 7:45?
Yes.
Okay. Where was I?
You were at the Cal State Northridge?
The lawsuit. The lawsuit.
7 sliders, John.
Yes, so please pray that this is explosive. It's open season on Christians and creationists, folks, in this country. It is just absolute open season. And that's why so many Christians are so afraid to stand up. And they're so afraid to tell people what they stand for and what they believe. Okay? God called us to not have fear, didn't He? He called us to be fearless and to trust Him and to walk out off the edge of the cliff. And come on out. That's my point. Come on out. It's been rough, but you know what? Everything's still attached. I'm still breathing. The Lord supplies me with plenty of food. But if all I can do, if all I do in this whole process is encourage others to stand up for their faith, and I'm not talking about being belligerent or ugly, we got to do it in love. We have to be people of compassion. The fruit of the Spirit is love, joy, peace, patience, goodness. All those things that Jesus exemplified. We have to mirror that. It's about surrender, isn't it? Especially guys. The ladies come by it a lot more easily, don't they? It's like it's built into you guys. The ladies, I'm saying. The men, it's about surrender, isn't it, guys? It's about surrender, which is hard for us to do, isn't it? Hard to surrender. But that's what God wants us to do. And He wants us to stand up. But let me tell you something else. And this is probably the most important thing you're going to hear tonight. When people ask me in the grocery line, how are you today? You know that's a great opportunity. Do you know that that's an opportunity for you to share Christ with somebody? And you might be thinking, okay, I learned all these verses in Sunday school, and I've been reading them in my quiet time, and I know Jesus wants me to share my faith, and you get tongue-tied and you can't say anything, right? Here's what you can do, because this one really works. How are you doing today? I'm doing great. I went on a dinosaur day. Suddenly, everybodybody's looking at you. Why? Because they haven't been on a dinosaur dig and they want to go on a dinosaur dig. Everybody wants to go on a dinosaur dig, right?
No.
And then I say, because everybody's looking at me, and I look at everybody while they're looking at me, and I say, I went to the Badlands of Montana, and I dug up a 48-inch long Triceratops horn. and I act it out. So they're getting the mental picture. And in that horn, I found soft tissue. And I squeezed my arm. Now they're getting this total mental picture, and it's amazing because that's when their jaws fall down. Because they're trying to process what I just said. Wait, you found a Triceratops horn and it was full of soft. We were in Sunday school on Sunday morning, and a young student at the Master's Seminary was visiting our church, and he'd read about me. And he was sitting around the corner. He has two young kids there bouncing up and down, so we're trying to have a conversation at the beginning of Sunday school class, and he goes, "You're the guy, right?" I said, "Yeah, I'm the guy." And he goes, "Wait, did I act the whole thing?" "Yeah, I did. I acted the whole thing out for him." And he goes, "Well, that means that," and he stopped. And I said, "Say it, say it, say it." And he's almost like he couldn't say, "That means they have to be young. That means this has to be young." Everybody gets that. Everybody understands that soft tissue doesn't last 1,000,000 years. You buried Fido in the backyard 10 years ago. If you go dig up Fido, in fact, kids, there's your science experiment. That's what you and your mom and dad are going to do now. You're going to go dig Fido up and bring it inside. I know, Mom. Yeah. Okay, on the porch. Bring it on the porch. And you're going to look for soft tissue. Kids, how much soft tissue are you going to find after 10 years? Right? We all know that. We all instinctively know that. So when I'm in the grocery line and I'm telling them I found soft tissue in a Triceratops horn that they know is 68 million years, they're processing it. And then one of them will say, "What does that mean?" And I'll say, "Well, if soft tissues are in dinosaur bones, then they have to be young. And if they're young, then the deposits that they're in are young. And if the deposits that they're in, and we find them all over the earth, by the way, if the deposits that they're in have all this soft tissue, then the whole earth must be young. And if the earth is young, then suddenly Genesis becomes a believable book of real history. And now I can go to Adam and Eve, and I can talk about the garden, and how they walked with God in the cool of the day, and how they blew it. They broke their relationship with God, and God had to curse them with death. But guess what? He sent Jesus. I can get to the gospel in 60 seconds after telling them what I found in Hell Creek, Montana. And that's what this is all about, guys. This presentation you're going to see tonight, if I ever get to it, it's not about dinosaurs. It's not about me. It's not about Cal State Northridge. It's about the gospel. It's about the truth about this world, how it started. Not how Satan has messed it all up. Not how sinful man has coated it with all this sin and all this destruction and all this confusion. It's about the gospel, that you and I need Jesus Christ, right? So that's what this is about, and that's what the journey has been for the last 2 years, 2.5 years. It's been so cool. We were on an Avis bus going to one of the conferences. We just gotten off a plane on the, and you get on the Avis bus and everybody's in a suit and tie and they're carrying their briefcases and they're all, "Yeah, I sold $500,000 last quarter. Really? Well, I covered all the West Coast last year." And it's business people doing their thing, right? "How are you doing?" "I'm great. I went on a dinosaur dig." Now all the suits are looking at me. And I found, and they're all staring at me. The driver of the Avis bus almost drove off the road because he was trying to talk to me seriously while he's driving. He was so excited. This guy was black as coal, too. He was the neatest guy I've ever met. I think he was from Ethiopia or Nigeria or something. And he was so excited, you know, where everybody, you know, had to be holding on to something. And finally they got off the bus and he didn't even help anybody. He wheeled around out of his chair, pulled out his phone and said, "Tell me everything you just said into my phone." Literally, that's how, this is a game changer, folks. This is a game changer, and that's why Satan is throwing everything he's got at us, because he doesn't want this out. Now I'll give you a couple more pieces of background before I go into the new stuff. Soft tissue in dinosaur bone has been in the scientific literature. I'm gonna give some dates, and I want you to raise your hand, okay? Since the 1990s, since the 1980s, since the 1970s, since the 1960s, yeah, since the 1960s. This has been in the scientific literature for 45 years.
I was going to ask you that. That was my main question. I was going to ask you.
Yeah. Why don't we know about it? Because it destroys their little paradigm. It totally upsets the apple cart, and they can't endure it. I work with guys because I'm on the board of the Southern California Society for Microscopy. I've been on the board for about 20 years. I was past president for 4 years. So I have a lot of contacts in the microscopy industry. I know people who make the slides, the thin sections. They grind this stuff down, they make the thin sections. I know labs all over the world that are doing that. Most of them tell me, we've been finding soft tissue in dinosaur bones for years and years and years, but we don't talk about it, we don't publish it, we don't advertise it. Why? It's because of this peer pressure of evolution and millions of years that have tamped this down. So people know about this, but Satan doesn't want it out there. Okay, so I got terminated, we have the lawsuit, the lawyers keep quitting. Pray for me. Right now I have 2 papers that are in secular press. What do I mean by that? I'm trying to publish on the world stage. It's getting hard. A lot of the editors don't want to talk about this. They don't want to publish your papers. I have one right now in the Microscopy Journal, an overview of the work that is this close to going in the journal. I've jumped through all the hoops that they wanted me to jump through, and it's this close. Please pray that these will get published. Acta Histochemica, this is the first journal I published in. I've got number 2, because we went back to Hell Creek, and we found soft tissue in the frill, which is that bony plate behind the head, and the condyle, that round ball joint that's at the base of the Triceratops head. We found loaded with soft tissue. And here are a couple of pictures of some of the osteocytes. Look at that beautiful cell. Now I'll tell you something else about some of Mary Schweitzer's work. Because when she first published her work, they said, no, this is sludge. This is literally bacterial poop. Okay? They called it bacterial poop. Maybe you've heard of the term biofilm. It's that stuff that grows on your teeth when you haven't brushed for 2 or 3 days. Yeah, if you want to look at biofilm under the microscope, just, Mom, I give him permission. Don't brush for 2 or 3 days. Then use a toothpick, scrape that off, put it on a slide, put it under the microscope. And you can be looking at bacterial poop. And so what one really smart researcher said was the bacteria eat these cells. They ate them 68 million years ago, because we know these don't last 68 million years. So the bacteria ate these 68 million years ago, and look at what they pooped out. It happened to be the exact same reconstruction of the cell they just ate. Oh, come on now. They call me a non-scientist. Let's be real, okay? You don't poop out things that look exactly like what you ate. You all know that, right? You know that, right? What year did Schweitzer publish? She began publishing in 2005. Actually before that, but the seminal work was 2005. So Mary then had to prove that this was not bacterial poop. So what did she do? She looked at the nuclei. Now that little round thing right there, is probably a nucleus. That's how well preserved these are. And so she used a very sophisticated form of microscopy, one that I was teaching at Cal State Northridge before they threw me out. And she used lasers in her microscopes to find proteins in that nucleus that only come from the nucleus and only come from reptilian-like creatures, because the other charge was, well, this is all just contamination. Now think about the contamination charge. Look at the beauty of these cells. They look like the cells I showed you before, right? But these are 68 million years old, supposedly. But you can tell they're cells. You can tell they're osteocytes, right? Now, somebody said, well, this is contamination. The osteocytes that you found in that bone, Mary, are contamination. Now, think through this with me, folks. The bone is in the ground 68 million years. Are all the osteocytes still there? No, they're gone, right? The bacteria ate them and pooped them out. We don't know what they look like now. Okay? But there it was, sitting in the ground, and so a bird, flying by, had a heart attack and smashed into the ground right above the bone. Smashed into the ground. And as it smashed into the ground, it broke its wing open. Its wing broke open. Because where are osteocytes, kids? They're in the bones, right? So in order for the osteocyte to get out of the bone, you have to break the bone. So, hit the ground, broke its wing. Osteocytes, before they died, in the bird, before they died, they said, oh, we gotta go find another place to be. This is what a scientist was telling us actually happened. So the osteocytes crawled out of the bird, crawled through the dirt, found the bone, found the right place in the bone, and lined up. You saw that one picture where I showed you, whoops, going the wrong way here, where I showed you these guys lined up. See how parallel they are? I had another picture that I was trying to put in here. I'll try to bring it up before we end. See how parallel these are? All these cells are all parallel to each other, and they're all in the same plane. They're like soldiers at parade, marching down in a parade. And so somehow, these bird cells crawled out of the bone of the bird, crawled through the dirt, crawled into the dinosaur bone, and all lined up perfectly before they died. That's what this guy meant by contamination. Now that's laughable. It was published in a journal. It shouldn't have even made it past the editor, right? But it did. So Mary quickly dispensed with that one. But then she did this work on the nucleus, and she found proteins that only belong in the nucleus. What kind of proteins did she find? She found histones. Reptilian histones. What are histones? You've heard of the DNA molecule, right? DNA. If you stretch that molecule out, it's 6 feet tall. Did you know that? That one molecule is 6 feet tall. Well, how in the dickens are you going to get that 6 foot tall molecule into a tiny little nucleus? Well, you fold it. You fold it, and 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 you fold it. And what folds it? Histones. Histones are the proteins that fold the DNA molecule into those little tiny X's and Y's that you see under the microscope. Histones. She found them. She nailed the coffin shut on what these are. She proved beyond a shadow of a doubt that these are dinosaur cells. Okay? Good going, Mary. She did her work. She did it carefully. She did it well. All this is published. She proved that these are actual dinosaur cells. So now you got a problem. You got a 68 million year old bone with dinosaur cells that are actually dinosaur cells still in them. Why are they still there? Can anybody tell me why they're still there or how they're still there?
Younger than 68 million years old.
That's one idea. But are there any mechanisms that would allow these cells to be there? 1 million, 2 million, 3 million? Is it possible? No. It's possible. Isn't it possible? It's possible. Is it probable? No. But is it in the infinite realm of possibilities? Is it a possibility? Yeah. So what do? They went hunting for a mechanistic, by mechanistic I mean scientific rationale for how these are here. And we're going to talk about that tonight. All right, everybody stand up, stand up, stand up, stand up. Stretch. Stretch. Shake. That's for sale.
It's for sale?
Yes. Debbie, take over. All of these pictures that have a green background and have pictures on them are in the book. Okay, so I'm not going to show a lot of them, but some of them are in there. And these are pictures of the horn when we first found it. As we continued to dig it out, we coated it and shellacked it and turned it over. So these are all from the old stretching. Now, you've heard about my original work in the Triceratops horn. I want to make a few comments about some new scientific tests that we've done that are pretty interesting. How can I do this in a way that's understandable? How many of you have had the doctor say, we need to run a complete blood panel on you, and so we're going to draw your blood and do a blood panel? Okay. And so you go in, and the ladies are cool because you're like, oh wow, look at that needle that you just put in my arm. The guys are like, what? 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 I know you're not like that, guys, are you? Yeah. And so they draw your blood and they send it to a lab and they do what's called a Chem 20. Chem 20. Now there's a museum down in San Diego, Santee, called the Creation Museum. Anybody been there? Okay. It's a great museum, isn't it? And it's attached to a company called Scanabodies. Did I put it on here? I don't think I did. Scanabodies. Scanabodies is a big company that studies human antibodies, and they make these little test kits, and they made a bunch of money. So they bought the museum from ICR when ICR left, and they've redone it beautifully and added some things. But they have a whole chemistry group in a big building behind the museum, and they said, we want to do a Chem 20 on your Triceratops. I thought, wow, that might be interesting. So we let them do it. And here in this chart, and I'm not going to go into this a lot, but they ran 3 samples, and actually just 2 Triceratops samples. One of them was, we call it control, because you want to see where your machine is operating at. So you run it like a blank, and you should get all zeros with everything. And then they ran these 2 guys. One they soaked for like 3 weeks in acid, one they soaked 1 week in acid. But I circled these numbers here. Why? Because they're triglycerides and cholesterol. Man, how many of you have been told about triglycerides and cholesterol? Yeah. How many of you are on a statin? Anybody on a statin? Am I the only one who's on a statin? You're on a statin? Okay, I know, I've heard that too. But these are numbers that they look at. These are lipids. They're fats in your bloodstream that they look at to determine how you're doing, because they say a certain triglyceride level, candidate for a heart attack, same with cholesterol. And so look at, we got numbers. We got 2.11 milligrams per deciliter. Over here, 2.34 milligrams per deciliter. We're getting values on a 68 million year old bone, right? Well, I don't think they're that old. But think about this. This is pretty interesting. First of all, the fact that we got numbers at all is astounding. So I talked to several different people about it. First, I talked to the Scanabodies people. They were in mild shock. They couldn't believe, because these guys are looking at human blood all the time, and they could not believe that they got any values out of this Triceratops horn. I think some of the chemists there are still on the old Earth, border there, and they were shocked. And then I was sitting and talking to them, and they were asking me, what does this mean? What does this mean? And they said, they must be young. I didn't have to say it. They said it. They have to be young in order to have these values. And I'll tell you why in a second. Now, as a tent-making thing, because I believe every ministry should have a tent-making thing, because Paul gave us the example of having a tent-making thing. That's the end of my sermon. As my tent making thing, I sell and service microscopes. So I was in a clinical lab, and I spoke to the manager, and I said, we got some values, and I quoted the values.
Look at the hemoglobin.
Yeah, well you're stealing my thunder. Be quiet, peanut gallery. I gave her these values, and she said, first thing out of her mouth, the test is obviously flawed. It's the test. It's not the sample. It's not the values you got. It's the test. And I kept talking to her about it, and she was getting more agitated the more we talked, right? And I don't want to lose this account. I mean, I've had this account for a long time. Finally, she said, your units are not correct. Now this is really not true, and I could spend a lot of time talking about that. But she kind of ran for the hills, okay? When she couldn't really answer me on the real facts, she obfuscated. Kids, that's your word of the day. Obfuscated has a B in it. So go home and learn that one, yeah? What does it mean? Anybody know, kids? She clouded it up. She confused it by going into the units. And it's a red herring. You know, you've heard of a red herring? So she kind of ran for the hills, and then she did not want to discuss it any further. And because I like to make money, I shut my mouth. But I'm in contact with her a lot, so we'll revisit that one. My primary care physician was really cool. Well, they didn't die from heart disease. But the values are pretty low. I mean, men are supposed to be around 200, 250, right? And so obviously they didn't die from heart disease. But then he goes, are you closer to cloning a dinosaur yet? You know, I want to see one. So I thought he was pretty cool. But let me just spend a minute talking about body decomposition. But then I want to go to, you know what, I'm going to skip this. Basically, there is scientific work being done to test the decay of cholesterol over short periods of time in dead bodies. This is a body post-mortem. They talk about the post-mortem interval. Why is post-mortem interval important? If they have a murder that they have to solve, they want to know what's the post-mortem interval. And they use some really old techniques to try to decide what this is. Now they're getting more scientific by looking at the decay of cholesterol. And basically the whole lesson from this is that if you go backwards in time, in 10 years, at this decay rate, if you go back 10 years, the Triceratops would be at a human target level. That's just 10 years. And this guy's supposed to be 4,000, 5,000, 6,000 years old on our calendar. So this is crazy. I could spend a lot more time talking about that. But yes, and you mentioned the hemoglobin. The fact that we find any hemoglobin at all is problematic for Mary Schweitzer. Why? Mary Schweitzer, as I told you, proved that these tissues are dinosaur tissues. They're not contamination, they're not biofilm, they are the real deal. Yeah? Everybody with me? She proved it. She did a great job. So now the scientists are saying, Mary, you did a good job, but we're going to take you to the woodshed. Because you painted us in a corner with these darn creationists, and they're running all over the place, talking about how dinosaur tissues are still here, and so if they can't be old, they have to be young. So you need to find a mechanism for how these things are here. Yeah?
Exactly.
This mechanistic explanation for why these tissues are still here. So she did that. She did that. And she used hemoglobin. But she didn't just use hemoglobin. And you know what hemoglobin is, right? Hemoglobin is a protein in your blood that is a machine. It's a great machine. It's a contraption in your blood that when in the lungs, it grabs oxygen, because oxygen fits right in there. And it's this machine that opens and closes. And when it goes through the tissues of your body, it releases oxygen, and it picks up what? Carbon dioxide. And it takes that to the lungs, and you exhale, and out it goes. By the way, hemoglobin is very good at capturing another carbon oxide, carbon monoxide. Yeah, okay? But she had to use the iron from the hemoglobin in order to do her experiment. What was her experiment? Mary Schweitzer, because the evolutionists were saying, you put us in a bad light, Mary, you put us in a bad light, you got to fix this thing. So she did what I call a 10th grade experiment. She took ostrich blood and chicken blood, and she soaked tissues in it for 2 years. She took tissues from ostriches, and I think it was just ostriches, but she used ostrich blood and chicken blood, and she soaked these tissues in that blood, and it wasn't just the blood, as you'll learn in a second. But this is what everybody's saying. The blood and the iron preserves the tissue. She soaked it for 2 years on a laboratory bench in an air-conditioned laboratory, and she said, she looked at it under the microscope and she said, voila, it is preserved. Therefore, the iron did it. Have you heard this?
Yes.
This is big. Everybody shout. Whenever online, when I get into an argument, or let's call it a discussion, they all shout out, it's the iron, it's the iron, it's the iron. But they haven't done their homework. And so my job is to go online and teach them what they should have learned. But there's a problem.
There's Mark.
Yeah. So, by the way, I really want you to go on to Mark H. Armitage on YouTube. You know how to do that? Go to YouTube, search for Mark H. Armitage, and there's a bunch of videos there. And I'm explaining this in great detail so you can study this and be able to answer this objection. The iron preservation hypothesis fails. This fails. Why? Number one, or letter A, anomalies in specimen handling. What do I mean? There are problems with the way the specimens were handled. And I'm talking about the dinosaur specimens. When you look at Mary's paper, the 2005 paper from Science, she examined a T-Rex femur. She gave it a designation number, Museum of the Rockies 1125. So that specimen was called Museum of the Rockies 1125 in 2005. In 2009, her paper in Science on Brachylophosaurus canadensis, she called Museum of the Rockies 2598. Now she studied these for these papers, and then she kept them in her laboratory. How? Where? Under what conditions? We don't know. Why is that a problem? Because in the 2014 paper, Proceedings of Royal Society, look at the numbers she used. Do those look familiar? Same numbers. Now that's important. This is a detail that scientists need to give up, be honest about. The same specimens were held 8 and 5 years out of the ground for an iron experiment. Why is this problematic? You take something out of the ground, you change it. It's going to change. Even if it's been in the ground 4,000, 5,000, 6,000 years. It's going to be different. Especially if you keep it in your lab for 8 years. How did you store it? What was it in? Was it in a liquid? Was it dry? What chemicals did you use? Who handled it? What temperature? Was water present? These are important questions. Why? Because she's making a thesis in the 2014 paper that iron solved it. Now, I could go into a lot more detail here, but I just want you to understand why the specimen handling is important. What were the storage conditions? How different was this from the soil conditions at Hell Creek? Biota, what were there organisms present in your laboratory while you were storing these tissues? Were there microbes? Were there insects? Do you follow me? That's called biota. Water, humidity, enzymes, temperature cycling, etc. Do you know that this bone went through the freeze-thaw cycle of Montana for at least 4,000 years. Freeze-thaw cycle. Freeze-thaw cycle. Water pouring through it for 4,000 years. And yet there's still soft tissue in it. Crazy, huh? So, this is important. Who maintained the chain of custody? You can have a case against you dropped in court, a criminal case, if they can establish that the chain of custody was broken on any evidence they have against you. Right? This is important. Was the hemoglobin degraded? Or was there a concentration of iron particles? Why? Iron particles become important because Mary says this is what did the preservation. And I'll show you. Many questions that have to be asked. All right. Letter B. Experimental characteristics. This is what Mary did in her experiment. And these are important things. When I read a paper in the literature about an experiment done, I want to know what they use, what equipment they use, what chemicals they use, what duration. It's called materials and methods. That to me is the most important part of a paper, materials and methods. No materials and methods sections were in Mary Schweitzer's papers. Do you understand what that means? Were they available? Yes. But I had to hunt through many websites to find them, and I had to have keys to get in. I had to pay fees to get into the Holy Grail. Yes. Okay, that's why people don't know this. That's why people are running around saying, the iron did it, the iron did it. When I say, hang on, slow down, let's read the materials and methods and let's look at what really was done here, yeah? Did you know that an anticoagulant was used in the blood that was collected? What does that mean? What is an anticoagulant, kids? What's an anticoagulant? You know?
Stops the blood from clotting.
Stops it from clotting. How many times in the last month, kids, have you gotten a cut and watched the scab form, like over a few days? Anybody had that recently? Yeah. That's called coagulation, clotting. Mary used an anticoagulant to collect the blood. This is huge. Now picture a dinosaur dying into Hell Creek Formation, and thank God there's a dinosaur dressed as a medic standing right next to him with a huge hypodermic injecting an anticoagulant. Okay, it's ridiculous, right? Well then why did she use it? She had to use it to preserve the iron. She had to get the iron out. So she kept it from clotting. Ultracentrifuges, not just centrifuges, big $20, $30, $40, $50,000 centrifuges were used to spin everything down. Why? She had to separate all the cells. All the cells, particularly the platelets. What are platelets? Tiny little blood cells that clot your blood. That had to be removed. Now this is before the experiment ever started. Okay? And I can picture all kinds of ultracentrifuges at the Hell Creek Formation where these dinosaurs had their blood ultracentrifuged. Come on. It's ridiculous, okay? And all the serum. Why did the serum have to be removed? Because it's full of clotting proteins. I'm trying to go quickly here. Finally, at the end, a molecular filter, a filter that filters molecules, was used to isolate specific ones. Why? They had to remove everything that coagulated the blood. Had to take it out, or the experiment couldn't proceed. Okay? Nobody knows this. Why? Because Mary has no materials and methods sections in her papers. Okay? Is this bad pool or what? Is this bad poker? More specimen characteristics. The femur that she found was described as a disarticulated element. That means it was split off from the body. Now, bones that are split off from the body and severed limb are going to behave completely differently from those that are still attached to the limb. And I could spend a lot of time here talking about iron oxide. You've heard of the rust belt. Anybody ever seen rust on your car or on an old tractor? Yeah, we know how highly destructive it is. She's expecting the iron from Fe2O3 to do the preserving, but we know it's mostly highly destructive. I wish I had time. I'll show you a picture of iron oxides under the electron microscope. These are about 100 nanometers wide. Remember, 1/100th of your hair is 1,000 nanometers. This is 100 nanometers. That's the iron particles. These are supposed to fix the tissue, but we use formalin. You've heard of formaldehyde that has a size of 7 angstroms. Tiny, 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 tiny stuff. The diameter of atoms to fix tissues. She's expecting a 100 nanometer sized object to fix tissue. I mean, the problems just go on and on and on with this. These are her pictures. I used her pictures when I spoke at the conference in Hartford last summer. And I put up one of her pictures and I said, how can this iron layer that's all stored in here be fixing all this when it's not in contact with it? And every PhD did this. Okay. And then I flipped her picture over, and it looked to me like it's pooling, like blood pooling at the bottom of a limb or a body, right? Other stuff I could talk about here. There's just all kinds of problems. But here's what I think happened. Over time in her laboratory, remember, she had these dinosaur specimens in her lab for 8 years, the T-Rex, 5 years on the B. canadensis. That's a long time to sit in a laboratory. Out of the conditions that they were in at the Hell Creek, yeah? Okay? I think that as the tissues dehydrated, these got drier, these iron particles which were in the bone, in the matrix. By the way, the Hell Creek Formation is known to be full of iron, full of iron oxide. I think that as they desiccated, these guys like water, and so they traveled and they surrounded the outside of the tissues. We call this adsorption. Okay? And I think that's what she's seeing. She's seeing what we call an artifact of adsorption from her tissues being in the lab for too long. Okay, and then let's ask the basic question. Why are they preserved? If iron doesn't do it, which I think I've shown, and you can see this in my videos on YouTube, why are they preserved? I don't know. I do not know. This is a little old stretchy piece from our book. I don't know why these cells are in these bones. I cannot give you any scientific reason. The only reason I can give you, which I think is that God preserved these cells for such a time as this. Joshua and Caleb wandered for 40 years in the desert. They had to suffer along with all the Israelites. They did it quietly, without grumbling and complaining. The shoes on their feet were what? Brand new. Brand new. God preserved them. And they're the ones that went into the land and took the land, right? Joshua and Caleb. And I just see that here in what God has done with these tissues. Why am I the one that's found these? I don't know. It humbles me tremendously that God has let me find these things. And again, this is not about me. It's really not even about soft tissue. It's about the gospel of Jesus Christ and reaching people, reaching through the layers of millions of years that these people are way down under, cutting through that, right to their hearts where their jaws hang down and they, what? And then preaching the gospel to them because they're open to it. You see, that's what this is about. All right, I got 5 minutes before I'm going to kick everybody out and we'll do part B, right? This is Nanotyrannus. Dun, dun, dun. Deborah, who's a great illustrator, drew these. This guy, for a long time, they thought this was T-Rex when they pulled up his bone. Very rare. Only a couple of his skeletons have ever been found. Very, very rare. But this is way different from T-Rex. The brain is shaped differently and it's cocked differently in the cranium. It's uplifted. T-Rex's brain was pointing down, so you picture him just kind of going, dun, 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 right? But Nanotyrannus, he was looking up, like those raptors did, remember? Kind of like the raptors, only he's 7 feet tall and 15 feet long. So he wouldn't fit into the kitchen like those raptors would, right, in Jurassic Park. Now he's a 3-toed dinosaur also, but his hips and his legs are made for running. And they call him, some scientists call this guy the cheetah of the dinosaurs. He could run 60, 70 miles an hour. You'd be trying to get away in a very fast Jeep, right? Where the mirror says, objects in the mirror are closer than they appear. Remember that, don't you? This is the dig we were on. Can you see us? That's me in the green shirt. And that's one of these over here. Oh no, you took the picture. But look at how expansive this is. And we're only digging one tiny part. Now I have to tell you, we're the only creationists who are allowed to dig at this dig. Because this guy that we've been digging with, a wonderful Christian man, loves the Lord, reads his Bible every day, okay? Somehow we got connected through a friend of mine at church, and he put us through a test, though. There was a couple of days, though, at first where he kept us at arm's length. But then, by the end of the dig, we were hugging, and he's anxious to see the results and anxious to have us come back. We're the only creationists to dig on this dig, and we know we found Nanotyrannus because we found the teeth. The Nanotyrannus teeth are way different from T-Rex teeth. I'm sorry, from T-Rex teeth. So we know we're digging on Nanotyrannus. We found a metatarsal. Remember, this is a three-toed foot, and this is the claw. Of course, this is one of the metatarsals. We actually found this one, not this one, but this one here. And I have already taken a Dremel and cut out a large section of this, and it's soaking in the weak acid to get the soft tissues out. But so far we've worked on vertebra. We have a couple of vertebra, and now we're finding the cells. See the cells we're getting out of here? So this is very exciting. Because this is a world first, guys. Just like the horn was a world first, this is a world first, and I'm hoping and praying that we can get this one published pretty quickly. So I'm going to end it there for part A. Thank you. God bless you. Hang around for part B.